Semester exam review. So for this graph, we're going to make these changes to this graph. Actually, we're going to describe the parameter change. So what this says is that we're going to take function m, which is this function right here, and we're going to translate it 3 units down. So this is going to go down 3 units. Remember that m of x is equal to y, so each y coordinate would be translated down 3. In this example, each x coordinate is going to translate 2 units to the left. Since it's inside the parentheses, we go the opposite direction. So it translates left 2 units. Here we have a reflection because all the y values are being multiplied by -1. So we have a reflection over the x-axis. So here the y value is 2. It becomes -2 when multiplied by -1. In this case, all the x values are multiplied by -1, so we have a reflection over the y-axis. So for example, the x coordinate for this point is 1, 2, 3, 4. If we multiply that by -1, 1, 2, 3, 4, we get -4. So it reflected over the y-axis. Here's your x-axis, here's your y-axis. Here we're taking all the y coordinates and multiplying them by 2. So we have a vertical stretch. All the y coordinates are going to get multiplied by 1/3. So everything's going to get shrunk by 1/3, so we have a vertical compression. And here we have a couple parameters. Here's an effect on the x, and this is the effect on a y. So we have 1 unit to the right and 2 units up. Draw a graph that would represent the height of a soccer ball versus time when the ball is kicked up in the air. Well, normally when a soccer ball is kicked, it starts on the ground. This will be time, our independent variable, and then this will represent the height of the ball. And we're just sketching a graph. Up in the air, gets up to a maximum height, and then it starts coming down. Solve each equation for x. So here we have an x on both sides, so we want to cancel one of them out. I like to cancel out the smaller of the two. So we have a -12 equals 3 plus 3x. And then solving for x, we're going to isolate it. So we're going to undo adding and subtracting first. Dividing by 3. X equals -5. In this case, we have to do a little simplifying before we start to solve. So we need to distribute first. And then we pick it up where we did with number 1. We have to cancel out an x. So I'm going to cancel out the smaller one. -6 plus 6 is 0. And then we just solve. So x equals 1/2. Okay, moving on. Alright, doing the domain and range. Here we have inequality notation. Remember that domain goes from the left to the right. So my furthest left point is going to be 1, 2, 3, 4, 5, 6, -6. And the domain is going to be all numbers greater than or equal to 6. And less than and equal to 1, 2, 3, 4, 5. Left to right. Range is going to be lowest to highest, so my lowest point is here. So 1, 2, 3, 4. And my highest point, 1, 2, 3, 4, 5, 6, 7. Okay, writing that in interval notation, we're going from -6 to 5. There's an equal sign because these are closed dots, so we use a bracket. -4 to 7. There are equal signs, closed dot on the bottom, closed dot on the top, brackets. And then set notation. The only difference here now with set notation would be all real numbers such that, and then you would put the inequality portion at the end. Same thing with the range. It's going to be all real numbers such that. Okay. All right. Here we have arrows on the left end and on the right end. So inequality notation is going to go infinitely to the left and infinitely to the right. And we use parentheses for interval notation. Least to greatest. Least to greatest. Range, its arrow is pointing down, so it's going down infinitely. And it's not pointing up, so it's not going up infinitely. The highest point here is going to be 1, 2, 3, 4, 5, 6. And that's a closed dot. So negative infinity is the lowest, 6 is the highest, and it's a closed dot, so it gets a bracket. Alright, so here we have the parent function for absolute value. Okay, we want to describe and sketch each absolute value function, so here's this one. Plot at least 3 accurately plotted points. So starting here at 0, 0, it says to move 3 units to the right. So 1, 2, 3. So 3 right, translated 3 units to the right. Then we have a reflection. So it's going to be reflected over x-axis. And we also have a vertical stretch. Okay, so from our new vertex, if you want to call it that, we go over 1, and then our a value is 2, and it's going to be opening down because it got reflected across the x-axis. So down 2. It's symmetrical, so we're going to go 1 the other way and down 2. So there's my 3 accurate points. Okay, so here we go. Starting off at 0, 0, we're going to go 1 unit to the left and 2 down. So that's going to be my new point. So 1 left, 2 down, and we have a vertical compression. Now, since these are lines, we can use this like a slope. So we could go rise 1, run 3. Now you can't do that with quadratic. Rise 1, run 3. Because quadratic is not linear. We can do that with absolute value functions. Okay? Alright, let's go ahead and skip that one for now. Alright, number 10. Simplify the following expressions. So if you remember, I to the 4th is equal to 1. So I want to see how many 4s go into 34. So that's going to go in there 8 times. So 8 of them. So 8 I to the 4ths. 8 I to the 4ths is just 1 to the 8th power, which is 1. So that leaves me with 2 i's left over. So I squared is negative 1. Here we have an exponent raised to an exponent, so that's going to be multiplication. So that's going to be I to the negative 2 times I to the 8th, which is going to give us I to the 6th power. And we know that that's made up of an I to the 4th times an I squared. And an I to the 4th is 1. So 1 times negative 1 is negative 1. Alright, so this one we got a negative in here, so we have to move that out. Move the negative 1 out as an I. So that's what we have there. Now we have to do a little simplifying. So the square root of 8 breaks down to 4 times 2. So we're going to have, this is 2, so 2i square root of 2. Okay, minus, and then the square root of 32 breaks down to 16 and 2. So that's going to be 4i radical 2. Now, we can subtract these because they both have an I and they both have a radical 2. So 2 minus 4 is negative 2i radical 2. And that is your answer. Alright, factoring by grouping. I'm going to go ahead and group the first 2 and the last 2, see what we get here. I might have to group them a different way, but we'll see what we get. So if I factor out 2 and a y squared, let's see, what do we get? That's going to be 3y minus 8. Now, can I factor anything out of here? No, I cannot. So I need to group them a different way. So let's try grouping 6. Maybe this is a v. Can't tell. Maybe it's a v. 6v cubed plus 21v. So I'm going to group those two together. And then let's group these two together.